To weather the twin crises of the planetary environment and civilization's resilience in the coming century, solutions usually proposed tend to fall into one of four categories. In this series, we are deconstructing these Ersatz Saviors one at a time, examining their virtues and their flaws.
The four categories of solutions are decreasing the number of children born through a modernization process called the demographic transition, growing the economies in poor countries, technological innovation, and a paradigmatic shift in human consciousness. Here we examine the third of these Ersatz Saviors, our belief in the unlimited capacity for human innovation, particularly technological innovation. There is certainly a history's worth of evidence to suggest that technological innovations helped make us the dominant creatures that we are, from fire, the atlatl, and bows and arrows, to irrigation, the plow, and the various yokes that bonded animals, to metallurgy, and all the innovations that went into guns and clocks, art, electricity, transportation, communication, and so forth. Technological innovations, along with clever economic innovations like private property, banks, and limited liability corporations, have steadily created greater wealth of food and everything else. These had the effect of providing for larger populations, and a top 10 or so % of wealthy elite whose time is spent innovating even more clever ways to appropriate the energy of the bottom 90% of humanity, and of all the rest of life, and of fossil fuels, nuclear energy, and myriad solar energies. This has been an especially powerful positive feedback system, called an autocatalytic feedback system, where each part in the system serves as an internal catalyst to directly increase some other part of the system. Tool use is not unique to humans. It's a natural phenomenon. Many animals use tools to enhance their natural faculties, including octopuses, New Caledonian crows, orangutans, gorillas, elephants, dolphins, chimpanzees, and bonobos. Humans, of course, have taken tool use to extremes, so that we literally have become cyborgs, machine-augmented animals. Glasses serve as enhancements for our eyes. Bicycles and cars serve as prosthetics for our legs. Clothes and houses as augmentations for our skin, and so on. These innovations have allowed humans to live anywhere and thrive most everywhere. So it is only natural that we would expect our technological prowess to help us meet the serious challenges of the present and future. And indeed, tens of thousands, if not millions of people, are for both selfish and selfless reasons researching and developing all manner of innovations. Everything from low-tech composting and drip irrigation to precision farming that employs satellite data, to high-tech alternative energy programs and smart, efficient transportation. And homes, to in vitro meat. However, attractive as technological solutions may be for us, especially if they hold the promise of undiminished lifestyles, there have been historically 3 deeply rooted and interrelated problems with their adoption. 1. Jevons paradox, also known as the rebound effect. 2. The creation of new and novel needs and desires. And 3. The unintended consequences of new technologies. First, Jevons paradox. In 1866, the English economist William Stanley Jevons wrote a book with the elegant little title of The Coal Question, an inquiry concerning the progress of the nation and the probable exhaustion of our coal mines. Jevons noted that technological innovations in England had made the burning of coal more efficient in many industries, and therefore the resulting products such as textiles and shoes were cheaper. More people could afford these products, so the demand for these products and for the coal needed to produce them actually rose. In effect, efficiency in burning coal did not decrease coal consumption, it actually increased it. Environmental economists in the past decades have found this rebound effect to be a common phenomenon. Almost all the cost benefits of efficiency are gobbled up in the purchasing of more products. Our landfills are littered with products made cheap due to increasing technological sophistication, and of course with what economists call economies of scale, which means products become cheaper as the scale of the production system increases. Walmart can sell a box of cereal for less than can a grocery store. For civilization's sustainable existence, the second problem with technological innovations is that all sorts of products that never existed before become necessities and everyday items. water bottles and soft drinks, refrigerators, air conditioners, and so on infinitely. The ways in which advertisement, human psychology, status, and the logic of capitalism are woven into this phenomenon are beyond the scope of this narrative. The first two problems, the rebound effect and the emergence of new and novel products, are often consciously manipulated for financial profit. The third problem is an unintended result of innovations, ones that the innovators themselves would in no way have foreseen, given the limitations of their worldview. What early farmer could have foreseen the consequences of agriculture, such as the complexity and sophistication of civilization that would be built on top of agriculture, or the human population explosion, stratified societies of winners and losers, deforestation and habitat loss for most of the world's creatures, the enslavement of animals and humans, the heating up of the entire Earth's atmosphere, and so forth. What tinkerers and inventors of the steam engine could possibly have imagined the industrial revolution that this technology would launch, with all its blowback? These were completely unforeseen and unintended consequences of incremental innovations in the techniques and social structures humans used to feed and comfort themselves. A classic study in blowback, or of unintended consequences, is the case of the Green Revolution, which I'll summarize here and will then present fully in a separate video. In the 1950s and 1960s, scientists and policy analysts recognized the global population explosion and its dangers, especially massive deforestation and famine. In response, scientists bred numerous varieties of three crops, wheat, corn, and rice, to produce high-yielding cultivars of these three species. Since 1960, globally the yields per acre in blue increased more than threefold, and the total food produced in red more than doubled. You'd hope that was the end of the story, famine problem solved. But blowback tends to be proportional to the power of the technology. No surprise, then, that the Green Revolution has created problems bigger than it solved. For example, the high-yielding hybrids of thirsty plants, drying important rivers and aquifers around the world. And industrial farming removes important life-sustaining nutrients, nitrogen, phosphorus, potassium, from the farmland. Petrochemical fertilizers are required to replace these important nutrients. Half the nutrients is taken up by the crops, half gets washed into the rivers and taken to lakes and oceans, where through a series of steps they cause mass die-offs of fish and other ocean creatures. There are about 400 such dead zones today, and the numbers are increasing. And since the vast fields of single-variety crops are easy pickings for pests, farmers must spray chemical pesticides on their crops. As pesticide application increases, so does pest resistance, and therefore crop losses have actually increased since the Green Revolution, indeed more than doubled. The biggest blowback of the Green Revolution, however, is that it prevented neither hunger nor deforestation. Remember the pre-Green Revolution population? Let's see what's happened since. We'll have to greatly lengthen the population axis to accommodate all the people that have since been added to the Earth. On this newly scaled graph, here is the 1950 population of 2.5 billion, when scientists began fearing the population explosion. Notice that the world population has actually tripled since 1950, and hunger has remained stubbornly high. Forests have continued to shrink, and will continue to do so, and farmland will continue to turn into deserts. And yet, despite all the food we grow, all the innovations developed, and all the destruction to the biosphere, still it hasn't been enough for us. Somewhere between 800 million and 1 billion people feel the gnawing pains of hunger each and every day of each and every year. 9 to 12 million people starve to death each year. 2 to 3 billion suffer micronutrient deficiencies. 2.6 billion lack access to proper sanitation. And over 1 billion people lack access to safe drinking water. And billions more people, mostly poor people in poor countries, are expected to join us in the coming century. Our species is facing challenges that are unprecedented in both their scale and in their depth. Because our impact has been planetary, disharmonized in everything from the atomic to the global, superficial solutions will no longer suffice. So what is a cyborg to do? If neither technology, nor economic growth, nor modernism are the solutions, then what?